Hello, now we're going to continue our work in algebra and recapping some of the work that we did in junior cycle, and I'm going to use my rectangular piece that I've drawn here to begin my examples. So if I have a rectangular piece of paper and I know that its width is x plus 2 and its length is 2x plus 1, first thing I'm going to look at is how I would write the perimeter of that shape. So capital P for perimeter, and I'm working with a variable x. So my input will be x. For different values of x, what is my perimeter going to be? Well, I know that a perimeter is just the width plus the length plus the width plus the length for a rectangle. So that's what I'm going to do. I'm going to add the width plus the length plus the width plus the length. And I look for my like terms, and I'm going to underline them because you can see I have quite a long list here. It'd be very easy to make a mistake. So I'm going to underline each x term. I'm going to put a dot underneath each constant term. And that helps me keep track of what it is I need to do. So I end up with 6x plus 6. And that is a function that gives me the perimeter of my rectangular sheet of paper for any value of x. So all I need to know is a value of x, and this function, p of x, will tell me what the perimeter of this sheet of paper is going to be, regardless of what size I make x. So a fairly sensible question would be what would be the value of p of x when x is 1? So this way of writing it here is the perimeter when my variable, the thing in brackets, is 1. So remember, in general, it's written as p of x. And in this case, I've set x equal to 1. And that's how I write this, p of 1, perimeter when x is equal to 1. So all I do is set x equal to 1. I end up with 6 plus 6 is equal to 12. Now, because this is a measurement, something I want to put down is units. I'm not given any units in this question, but I know I'm measuring some kind of length. The perimeter is a length. So I want to say to my examiner, because we're thinking about our final exam even now, I want to say to my examiner, I know that this is a unit of length. You haven't told me what unit you want, but I know that this is a measurement, so I'm going to say units. Now, in terms of the language of functions, if I write down p of x is equal to 6x plus 6, this is called a first degree polynomial. The reason because it's called first degree is the highest power in it is x to the power of 1. If I had x to the power of 2, I'd say it was a second degree or a second order polynomial. If I had x cubed as my highest power, I would say it was a third degree or a third order polynomial. So this is a first degree. First degree polynomial. So anytime they're asking about degrees or orders, they're just asking you what's the highest power on your input variable. And your input variable, sensibly enough, is the variable that you're going to change here. So it would be the x. What values of x would I put in to get out a particular perimeter for my shape? Now, if we look at what the area of that shape would be, I'd want the area in terms of x. That would be the width multiplied by the length. So I would take the first term in the first bracket and multiply it by the second bracket. I would take the second term in the first bracket and multiply it by the second bracket. And I'd multiply that all out. (2x squared plus x plus 4x plus 2. Gathering like terms, that gives me my area in terms of x. So AX for area in terms of x. Now a fairly sensible question might be, if I know that my area is a particular amount of units squared, what would be the value of x that would give me that? So if I measured a piece of paper and I found that the area that AX was equal to 9 units squared, what would the value of x be? If I know that this is my answer, what must x be? Well, this leads me back into work that I did in junior cycle. I know that AX is 9 units squared, so I set it equal to 9. And I see now that I have a quadratic that I want to solve. So now let's go and solve it. So I'm going to subtract 9 from both sides, or depending on how you were taught, I'm going to bring everything over to the left. And I end up with 2x squared plus 5x minus 7 is equal to 0. And now I know that I'm going to solve this quadratic. So I'm going to multiply my two numbers on the end. And I end up with 2 by minus 7. We don't forget our signs. Gives us minus 14. What are the numbers that multiply together? What are the factor pairs of minus 14? Minus 1 and 14. Or minus 2 and 7. Or 1 times minus 14. And 2 times minus 7. So those are all of my different possibilities. I know that I could also use the minus b formula, and it's important that we have that tool in the back of our minds. And I see which combination is going to add up to plus 5. So I want the end numbers to multiply together to give minus 14, and I want the same pair of numbers to add together to give plus 5, to give the number, or that's the coefficient of x. And I see that plus 2 minus 2 minus 2 plus 7 adds up to plus 5. So then I'm going to break that up. My plus 5x I'm going to break up into a minus 2x plus a 7x. Minus 7 is equal to 0. And I know that this hasn't actually changed the question, because minus 2x plus 7x is really 5x. So this hasn't changed the question fundamentally. Now I'm going to factorize. I'm going to take what's common to the first two, what's common to the second two. I end up with 2x on x minus 1 plus 7 on x minus 1 is equal to 0. I forgot a key part of this question. My apologies for not writing it down. X is an element of n, which means x is a natural number. I should have had that written down at the beginning. My apologies. So, x is an element of n. Now, I want to factorize this completely, so I end up with 2x plus 7 on x minus 1. Breaking that up into two pieces, I get 2x plus 7 on x minus 1. And they're both equal to 0, because this multiplied by this gives 0. So this could be equal to 0, or this could be equal to 0, because any number multiplied by 0 is 0. So both answers must be valid independent of each other. Rearranging to get x by itself. I find that x could be equal to minus 7 over 2, or x could be equal to 1. and I have that x is equal to 1 is going to be my only valid answer because I know that x is an element of n. So my apologies again for forgetting to write that down at the beginning of the question. This type of thing where x is given a restriction, where your answers are given a restriction, is going to be extremely common on the exams, where you are given a situation where you'll get two seemingly valid answers, but you must know that one of them is not valid because it doesn't meet one of the restrictions that you are given at the top of the question. This is an extremely common way of knocking you back from 10 marks in a question back to 8 marks or 7 marks, or 15 back to 12, because we didn't recognize that one of our answers was not valid because of a restriction they gave us at the beginning of the question. So spotting things like this is going to be very important for our questions moving forward to be able to do well on our exams. Now, our last bit is on some formal functions notation. We've already effectively looked at some of this in our earlier examples. If I had a function given by 4x minus 3 and I was asked what f of 3 was, I'd just sub in 3 anywhere I had an x and solve that. And I get 9. Or I could be asked something like f of x is equal to 1. Sorry, is equal to x, I should say. F of x is equal to x. What's the value of x that makes that true? So I'd write down 4x minus 3 is equal to x and rearrange to get x by itself. So plus 3 and minus x. So I'd end up with 3x is equal to 3. Divide both sides by 3. And x would be equal to 1. Or I could get combinations of these types of functions. Or I could have f of x minus 2 times g of x. So these would be two functions subtracted from each other. And I'd just sub in what the functions were. And 3x. Now 4x minus 3 minus 6x. Subtract my like terms. And I always write my highest power of x on the left, going down. So I'd end up with minus 2x minus 3 for my final answer. So we can see what functions are. We have functions where we have a particular thing that we want to know about, say perimeter, and we're able to write down an equation that tells us about what we're looking for. So the perimeter in our top example was going to be 6x plus 6. So for any value of x, we're able to work out what the perimeter is. And likewise for the area of any shapes, we know lots of equations for area and volume, and we're able to use them to find functions that describe the area and the volume of different shapes. And we also know about our general functions notation. And finally, and very importantly for our final exams, we have restrictions that they give us at the beginning of the question, which come to be important at the end for picking which answers are valid. So those are our different bits of recap of our functions that we would have done before.